Okay, morning everyone. Let's have the attendance taking first. 陳許廷陳學家.
Here.
Yeah, thank you. Love you here. Good. Let me see. The other guy. 鄧家傑何偉林.
No, I know.
鄧家傑 here? No? Oh yeah,
Here.
I can see you. 何偉林. Are you here? No. 林俊軒林成漢.
喺度。
林俊軒 here. 林成漢.林成漢 no here. 李佩恒鄧俊熙.
Here.
Yeah. 鄧俊熙 are you here?
Yes.
Yeah, thank you. 鄧浩俊黃俊熙.
你好。
Yes.
喺度。
Yes. 黃奕朗鄭浩明.
Here.
Yes. How about 黃奕朗? 黃奕朗 are you here? No. Oh yeah, I can see.
Hello.
Are you just wake up?
No， 我個咪唔知係有時用唔到。
張思維馮家謙.
Hello.
Yes. 何孝日何麗妍.
喺度。
Yes. Yep. 郭俊熙朗力.
Hello.
Hi.
李晴梁家傑.
Hello.
梁家傑 here. How about 李晴? Yep. Good. 李澤星李建樂.
Hello.
李建樂 yeah here. 馬家樂吳漢一.
Hello.
吳漢一. 馬家樂 Yep. Good morning. 魏俊滔譚君佑黃成軒.
喺度。
譚君佑 here. How about 魏俊滔 and 黃成軒?
Hello.
Yep. Okay. So this is the hopefully it can be the last face-to-face lesson. I don't want to have it. So today we come to the other chapter is on covalent bonding. Okay, so we have got two more structures to tell. So first of all, I would like to show you that video series, right? I do think it's a very simple yet easy to understood web series such that you can get to know what it means by covalent bonding. Okay, so I would like to start from here. Can you see that with the sound?
Covalent bonds. In this video, you are going to learn about covalent bonds, how they are made, and how they form. If you haven't seen it already, first have a look at our video, Structure and Bonding. Only the noble gases exist naturally as single atoms. All the other elements of the periodic table have partially filled valence shells, or outer electron shells. Atoms bond by swapping or sharing electrons in their outer shells. When very different atoms react, like metals and nonmetals, they normally swap electrons. This is ionic bonding. But when similar atoms react, like nonmetals combining with other nonmetals, they share electrons. This is covalent bonding. Nonmetals are found on the right-hand side and upper part of the periodic table. Some common nonmetals are carbon, nitrogen, oxygen, and the halides. They have shells of electrons that are normally half or more than half full of electrons. Since they have a strong attraction for a few additional electrons, it is energetically unfavourable for them to lose electrons, so they share electrons by overlapping orbitals. This makes a bonding orbital, or covalent bond, that contains 2 electrons. If there is space in the outer shell, a non-metal atom can form double or triple bonds, like in oxygen or nitrogen. In the displayed formula of a compound, we represent a covalent bond with a straight line, like this. We can also represent a covalent bond as a dot and cross diagram. These diagrams show only the valence electrons. To learn more about dot and cross diagrams, watch our video on dot and cross diagrams. Covalent bonds are directional, which means they are in a fixed position, like holding hands. This is different from ionic bonds, which are formed with an electrostatic attraction between charged ions. The overlap between orbitals means that the atoms in covalent bonds are very close. These things make covalent bonds strong. There are 2 kinds of covalent structure: small molecules, like water, and giant compounds, like diamond. Because the electrons in the bonds are evenly shared, bonds are not polarized. There is little attraction between molecules, and forces between molecules are weak. Compounds made from small covalent molecules have low melting and boiling points, and are volatile. They also don't conduct electricity. Carbon and silicon tend to form giant covalent compounds. These bond in the same way, but instead of forming small molecules with 1 or 2 bonds, they form 4, making up huge lattices or chains of many, many linked up atoms, the basis of the organic chemistry of carbon or the chemistry of rocks.
Now, this one, I would like to remind you that these 2, they are just element or compound. Okay, the pure carbon on the left-hand side and the pure silicon on the right-hand side. So, based on this structure, what is that? It is diamond. It is in form of diamond, 金剛石 or 鑽石. So the silicon is another structure. So if you are tilt at an angle about 45 degrees, turning clockwise, and you may see the structure very similar to this. Okay. So you may find carbon and silicon, they are of pure element, and they also have covalent bond. So this is what I'd like to remind you, right? This one, a little bit, the wordings should be refined. It's not compound, they are elements.
One common example is diamond, which is made of carbon. Each carbon atom forms 4 covalent bonds because it has 4 electrons in its outer shell to share and has space for 4 more. If every carbon atom forms 4 bonds with 4 other carbon atoms, and each of these forms 4 bonds with 4 other carbon atoms, and each of these forms 4 bonds, we very quickly end up with a very large structure. These compounds have very high melting and boiling points because you have to break covalent bonds rather than intermolecular forces to make them free enough to act as liquids or gases. The covalent bonds hold them rigidly in place in the giant lattice. Allotropes of nonmetals bond covalently. Allotropes are different structures of the same element. You can learn more about these in our video, Allotropes of Nonmetals. So to finish, here is a challenge for you. Which of these compounds are covalent? Pause the video for a moment whilst you think.
Do you know what is the answer? Well, you know.
Yes. CO2.
CO2. Just this?
No. CO
，That too.
之後仲有 CH3OH。
The three. The first three.
Silicon dioxide.
Silicon dioxide. 4. How about C70?
I think yes.
Yes, still yes. Okay, really? So let's check the answer.
Have you considered their physical properties and where the elements come from on the periodic table? Solved it? Okay. The answer is all of these compounds are covalent. Carbon dioxide, carbon monoxide, and methanol are all small molecules.
Do you know what are those 3 in Chinese? You know it? Do you know that 3 substances? What are these?
二氧化碳，跟住 CO 係
Carbon dioxide for CO2. How about CO? We call it carbon. Just one. Yes, just one O. We call it monoxide.
一氧化碳。
Yes, 一氧化碳. How about the one bottom? What is that? Anyone who can check? CH3OH, what is that?
甲醇。
Capson. Good. Capson. So in the English name is called methanol. Methanol. So you cannot drink it. Do you know why? You cannot drink it. Somebody will think that it is alcohol, right? But that capson, methanol cannot be drunk. Do you know why? It's toxic. Okay. It will cause blindness. Okay, capson. While yuson, it is the common alcohol that we are having with the formula CH3CH2OH. Do you remember the in the very first lesson we were given that that worksheets, right? I asked you guys to write down so many different types of molecules, compounds, substances, right? I just include yuson, ethanol, as example. It is a common alcohol. We call that ethyl alcohol. Don't you know that? Ethyl alcohol. So this we will tell you the connectivity of atom. We've got CCOH here, and then HH. We've got HHH, right? So what does that single line means? They're just covered in the video. What does that single line means?
One line means that each atom share gives out 1 electron.
Give out. You want share, not share. Okay, so what we will call it in simple terms, a single covalent bond. So you may heard of the video. There are so many different types of covalent bond. One of them is single bond. We've got double bond. We've got triple bond. Okay, so we will see one line here. We call it single bond. One more thing, I'd like to talk to you more about this because of current epidemic situation. Ethyl alcohol, right? It is used to kill germs. In the hand sanitizers, and also some other things like alcohol pad, you may have that ethyl alcohol here. What is the percentage? What is the percentage you use? You know it? On the market, what is the percentage you use?
70.
70, yes, about 70. Indeed, the answer is about 60 to 80. Okay, because for that range of percentage, the concentration is high enough, okay, to dissolve the outer coating of that bacteria. Okay, the outer coating of bacteria will dissolve. Okay, will dissolve the outer coating of bacteria such that you can kill germs. But if you use at a higher concentration, just like 90-95% ethyl alcohol, you may even make it harder. So it will preserve the DNA there. Okay, similarly for the virus. Okay, and also the virus. So we have got some coating outside, and you are going to dissolve that, the outer coating. Now, and besides having this, Cyrus, tell me, we have got another type of alcohol to use to kill germs. Now, don't tell me it's methanol. Methanol is not. Okay, methanol is toxic to you. On the market, we've got another type of alcohol. Maybe I give you a hint, so you check it against your hand sanitizer or maybe alcohol pad and try to see if you have got another type. What is that? Now, it is the common name, ethyl alcohol. I would like to mark it here. This is not the proper name. It's common name only. So the proper name, the chemical name is called ethanol. Have you ever heard of the third type? We start from the word I. Have you ever seen that? Iso? No? Isopropyl alcohol. Have you ever seen that? Yes, very good, Li Jiaxing. So what is that? What is that? Isopropyl alcohol. Are they the same as ethyl alcohol, Li Jiaxing? In Chinese, not. So what is the difference? In Chinese, we call that 乙丙醇. So the common the chemical formula of this is CH3, CH bracket OH bracket CH3. So the common the chemical name we call it is propane 2O. So why is it 2? Because we have got carbon position 2 having this OH. Whenever you see that OH, what are they in common? We have got 3 alcohol, right? What are they in common with that? We have got OH, OH, and OH. Whenever I see OH here, we call it alcohol. But different types of alcohol are there on the market. It's not a difference in the smell, taste, but indeed the chemical structure inside is different. Okay, so you may see that this is 乙丙. So it's also commonly used alcohol to kill germs. 乙丙. So the one on the left-hand side is a little bit cheaper. Okay, this one is cheaper. While this one is a little bit more expensive for ethanol. Okay, but if you want to compare the smell, ethanol smells better. Propane 2O, isopropyl alcohol, smell a little bit strange, quite strange as an alcohol. Do you know something about this? Now, this is what you may know about the molecule. Oh, so we come to a very big family, right? For those who want to know more about this, you will know it in Form 5. We call it organic chemistry, 有機化學, another family. Or telling molecules, but because we have got a huge combination of atoms connect together. Okay, so just to give you some of the taste of what is that. So it's more or less related to our daily life. We continue.
Organic molecules form covalent bonds between hydrogen and carbon. C70 is a fullerene, a carbon molecule shaped like a rugby ball, closely related to the Buckminster fullerene.
Now, this is C70, a type of fullerene. Okay, Buckminster fullerene. They just mentioned like this. So what is that? And you may see with 70 or C60, right? We have got so many C. That molecule is made up of 70 carbon atoms. They connect to each other. While the shape of this, take a look on that, you may find it is made up of what? It is made of hexagon. Sometimes by so many hexagons. And sometimes we may find it as pentagon. Can you see that? 5-sided 5-sided polygon, and we have got a 6-sided polygon. So we would, it seems like a very traditional soccer. The traditional soccer, the football, okay? So you may find black one and white one in the very, very past. They're very traditional soccer ball. And remember this one, it is not an compound, it is the element. Why? Because we don't have any other element, just carbon. Just carbon, okay, you see that? So, or diamond is one type, C660, 70, all those, they are just another type of carbon. So what are they? What are the difference between them? It's about the way to arrange, okay? It's the way to stick the ball together, to stick the atoms together. Okay, in chemistry term, we call it bond. They try to bond it together in 3D sense differently. So we will call that different materials. Okay, so we continue.
Silicon dioxide is a giant covalent structure and just like diamond, but has oxygen atoms bridging between 4 coordinate silicon atoms. Hopefully, you now feel confident identifying covalent compounds and recognizing their properties.
So, what do we have so far? We have we come to this family of covalent bonds, right? So we have mentioned something about a covalent bond. To start with, let's have a consolidation of what you know, what you heard of the ideas, and I would like to show a right screen here, and I would like to write down your concern. Okay. Shall I invite somebody to tell me what you know? Just 1 point only. It doesn't matter. 等好咗. Just give me, yeah, just give me 1 point that you may know about this. Oh, maybe I put it this way. Let's do it together because we want to have more more interaction actually. So you may see the chat box, right? So all of you, could you please help type what you understand about covalent bond or anything related to the video. I need 1 sentence, okay? I need 1 sentence. One thing that already impressed you. Just write it down. So on the left-hand side, you will see the whiteboard. As for some people who want to draw something, you may use this to draw something related to covalent bond. Okay, I give you about 2 minutes. Let's have some gathering of the information. The element use the electron together. Use electron together. What does mean by that? You mean bond? You mean bond together? Or you may heard of some term like high melting point. Is that all? Is that all substances have high melting point? Any example? I may also see some the video showing it is low melting point. So any example? Any example? Okay. 2 atoms share the electrons. Okay, good. Sharing of electrons. Okay, so electrons, what is that? The outermost shell electrons will be shared, right? So we will call it as covalent bond, which is different from ionic bond, electron transfer. Okay, it is different. What else? The elements don't need to be oppositely charged. But how about bonding? Bonding, is it a type of electrostatic attraction? Somebody say yes, somebody say no. Now, silica, what is that? A diamond? Silica, what is mean by silica? Yes, we call it quarks. Now, both they are just common name. What is the chemical name? We call it silicon what? Dioxide. Okay, or you use the word silicon 4 oxide with the chemical formula SiO2. Carbon dioxide, low melting point, poor electrical conductivity, you mean, right? Poor electrical conductivity. Good. What else? Now, you just mentioned something about properties. Now, properties, but how come we will say it as a sometimes high, sometimes low? So indeed, it belongs to two structure. Okay, it belongs to two structure. The first one, the first structure, we call it as giant covalent structure. While the second one, it is simple molecular structure. Okay, any more? And you will know this one by one later in the coming week. What else? Maybe you have got some of the core concepts of covalent bond already. Now, first of all, indeed, any substances related to covalent bond would exist as two-way. One is giant structure, the other one is simple structure. The difference between them, giant structure, is something whenever you will see something like this, okay? We've got forehand and then forehand and then forehand like this, right? Extended network. So we will say it as a 3D lattice. How about this? If you have got small low melting point, very often they will exist at maybe 2 at a pair, right? Or maybe sometimes 3 at a pair, right? So you may see CO2, right? CO2 this must be triatomic. While in between them, they are weakly held by forces. Have you do you realize the video, right? They just tell you they are now deal with some weak force. Okay, so but for this part, all those they are just strong bond, which is covalent bond. The covalent bond is also found here. But once we talk about change in state, such as solid from solid to liquid, liquid to gas, we are dealing with those overcoming the dotted line only. Okay, the green dotted line only, but not the red line. Okay, so we will get to know the difference between them. Why not noble gas have covalent bond? Noble gas.
They don't share electrons with other.
Why not? It's just a phenomenon. They don't share.
It's because they have a fully filled outermost shell.
Yep, fully filled outer shell, which gives it the atom very stable. So what I want to mention is noble gas. We have got fully filled outermost shell, which make it stable. So noble gas, right? So you may find no covalent bond there. So according to the periodic table, you have already gone through all types of the bonding. Okay, on the left hand side, metal, metallic bond. On the right hand side, non-metal, semi-metal. We try to deal with covalent bond, except noble gas, right? Noble gas, okay, no bonding. But we have got some weak force holding those atoms together. Okay, get my point. Now, what we mentioned is just element. How about ionic bond? For elements, we will not tell anything about ionic bond. Okay, ionic bond is just for compound. So in particular, we call it ionic bonding, ionic compound. Just like usually it is made up of metal and non-metal. While you talk about covalent bond, we talk about non-metal. or sometimes semi-metal. While they exist, it's not just compound, but also element. So all of you, please mark it down. Element or compound, they also show it as we have got covalent bond inside. But for ionic bond, it must be having compound, ionic compound. And usually it is made up of metal and non-metal. Okay, I do hope this one gives you a start to get to know what is that in the book. Questions? Questions? Now, if not, shall we have a sharing of the book items? Let me see. Yep, here we are at chapter 8. So you may refer to book on unit 8. Okay, page 110. Take a look. First of all, if you want to talk about covalent bond, we are dealing with some, as said before, non-metals. Sometimes semi-metal is also be included. Okay, so sometimes. Okay, so they would manage it by sharing the electrons. So I've just said to you that type of sharing of electrons occur at the outermost shell. So we better mention it as outermost shell electrons. While this is the covalent bond, it is different from ions because for ions, the relationship between them is just gain or loss of electrons, gain or lose of electrons. So you may see this one, okay? Gain or lose. So for metal, they tend to lose electrons, while for non-metal, they tend to gain electrons. How about covalent bond? Just like hydrogen, for example. Hydrogen, we have got only one outermost shell electrons in the outermost shell, the only one electron. So in case hydrogen want to lose electron, what will they form? Hydrogen atom. So we have got two strange cases. One is hydrogen ion. The other one is hydride ion, right? But we have got that two ion, very strange. And this one usually bonded with the group 1 elements, just like lithium hydride, okay? But not for the other highly charged ions, highly charged cations, because a hydride ion here, we've got only 2 electrons there. So it is rather unstable, okay? It's rather unstable. So we would be bonded with the ions which have a small charge, but is still positive. How about positive ion? Just like hydrogen ion. Hydrogen ion, they would not exist freely for example, in air. They will not freely exist in air. Okay, because you may find that hydrogen ion, the environment is that no electrons, just 1 proton, which means that this one alone is highly unstable. Okay, it is highly unstable. So what would they exist? They usually exist in aqueous medium as what? H3O+. We call that, oh no, Mr. Chin, or you just tell me that no quiz. How come I see that formula again? H3O+, hydronium ion. What is that? It is a type of hydrated hydrogen ion. So which means, what is mean by hydrated hydrogen ion? So the water is surrounding, the water molecules surrounding that hydrogen ions, okay, to form the more stable species. We call that hydrated ion or hydronium ion. How about hydrogen atom itself? Itself, it is unstable. So they will find their own way to make it stable. Okay, so how about when they have the two hydrogen atom, they meet, they will make a single covalent bond by sharing of outermost shell electrons. Only electrons they will share. So once I share this, we call that bond pair. Bond pair. Pair means two, bond involving a bond. So a dot and a cross will tell you the origin of the hydrogen atom, of electrons from two different hydrogen atoms. So we'll call it hydrogen molecules. So H2, it is in form of the gas at room temperature and pressure, which means that if you talk about that hydrogen diatomic molecule, okay, so we would have a very weak force holding weak force. They were holding the molecules of hydrogen together. Okay, can you get my point? While the covalent bond is not that the blue one. What I want to show you is the green one. Can you see that? This one, it is a bond. So where can you find the bond? The bond is in here. It's in here. It's in here. It's in here. Can you get a point? It is the covalent bond. Now, from the distance between them, you may know that it is strong because it comes closer. Can you get my point? So this is what you know about hydrogen. Why is it not octet? For the first shell, we just have duplet and it is already stable. Remember, so for the first electron shell, it can only accommodate two electrons in the outermost shell, according to 2n square rule. Do you still remember? 2n square rule. So you may find it is the first shell, n is equal to 1, so you may know that the maximum accommodation of electrons is just 2. Okay, do you still remember that? So covalent bond is just a form of sharing of a pair of electrons. Very often it works in pair. Do you have any questions so far? Now, once you have got this, we may speed up. Try to think of what is that. What is that first of all? Questions? Now, take a look on this. So, what is meant by covalent bond? Covalent bond is indeed a electrostatic force of attraction. Again, something positive and something negative. Between what? A positively charged nuclei of the two bonded atoms is something somewhat positive, while the negative charge shared electrons is somewhat negative. So you may see the attraction, if you show it in green here, it is in terms of an attraction. But of course, you may, from this diagram, that holds what? That holds the two atoms together. Okay, remember, because we have got positive nucleus and positive nucleus that hold the bonding electrons towards themselves. So we will call it as a directional bond, 有方向性嘅, which is different from ionic bond and metallic bond. For ionic bond and metallic bond, we would mention it as non-directional. Do you know it? We mention it as non-directional. It is different. It's different. Try to take a look difference between the two. So that type of holding force, it is we call that covalent bond. So remember, the covalent bond they will happen between the atoms. But how? As I said before, somebody say that there's no positive, no negative. The answer is wrong. We still have positive and negative, but all those can be found within the atom. Okay, the negative, it is the bonding electrons. Okay, it is bonding electrons, it's negative. While the positive, it is the two nuclei involved in covalent bond. Okay, can you get the point? So this is the definition I would like to address your attention. And for hydrogen bond, we would have it like this relationship. It seems like two hydrogen atoms, they would try to cross the arms of each other, but at the same time, they want to get that electrons. Okay, so which makes them bonded together. For hydrogen gas, it is a diatomic molecule, which means two atoms. Two atoms make it together to form a molecule. Okay, molecule is of that unit. While diatomic, which means two atoms. But for noble gas, it is monoatomic. It seems that means it's single, just like neon, argon. But we will not say there is a neon too. No, we're just neon argon gas. But for hydrogen gas, we will not mention H gas. We call that H2 gas. Can you get my point? So in which it is all those, they are just in pairs. Okay. So the way to show it is not just H, we call it H2. That type of formula, we call it molecular formula, which tells you the exact number of atoms of each element present in the molecule of a substance. For example, if you talk about H2O, which means two hydrogen atom plus one oxygen atom. For CO2, so you may know that it is one carbon atom and two oxygen atoms. Can you get my point? So the molecular formula, they will show you something like this. For chlorine, it is also diatomic. While chlorine, we are looking for what? We are looking for octet. Can you see that? How do I see it? Is octet. Octet. If I circle like this, they try to include that electrons that shared from another chlorine to himself. So maybe his partner, another chlorine atom, they also think it's similar. Okay, they try to count the shared electrons as well as himself, and try to tell the others that they are obtaining octet. Now the difference between ionic bond and covalent bond is that covalent bond, it seems like in Chinese we call it AA, right? A type of sharing. Okay, a type of sharing of substances. So this time is a sharing of electrons. Okay, so it is what you may find it here. So you may find something more strange, in which we have got this one. This is a bond pair, right? How about the other? They try to make it in pairs, right? Those making pairs, we call that lone pair. Lone pair electrons. So what was that? It is unbonded electron pair. About the bond pair, of course, you are now involving bonding. Okay, so not involved in bonding for covalent bond. So remember that two terms: bond pair, lone pair. How about oxygen? Let's have a try. Oxygen. How many bond pairs are there? How many lone pairs are there? Or maybe you find it quite strange, Mr. Chin. Can I say a pair or two pairs for bond pair? No, you may find a double bond, right? Can you see that? We've got a double bond here. So in which each oxygen, they will share two outermost share electrons to make a bond. So this one, it is a stronger bond, much stronger bond than single bond. Seems like what? It seems like a stronger spring, okay? A thicker spring. 彈弓啊, it seems a thicker spring. The stronger spring that will hold that two atoms together. So you may see that in this case, because for oxygen, it belongs to group 6. Okay, it belongs to group 6. We have got two more electrons to make it octet. So what can we do? Is to have asking for the sharing of two electrons such that you can have 2 more electrons for them himself. But of course, that type of thinking is just based on one way of thinking, one way of thinking. Indeed, the others, they are also thinking the same. So the overlapping area is not something extra. It's just a concept of sharing. Okay, so while each atom itself, they will treat those shared electrons as the electrons by themselves, owned by themselves. And you think it is octet. Can you get a point? So nitrogen, we're still triple bond. Why is it triple bond? It needs 3 electrons to be on octet, right? So what can we do is to find another atom of nitrogen and asking for having sharing of 3 electrons from himself. So you may get a triple bond. So the way to show it is just 3 single line. Okay, can you get a point? Can you get a point? This is what you know about nitrogen. Any questions so far? Now, if not, it's your turn. Now, I would like to show you this one, okay? It's the easiest up, this time with the answer first. The fluorine exists as diatomic molecules. What is that as diatomic? Diatomic molecule means a molecule means of 2 atoms that bond together, okay, di. So we have got several types of monoatomic molecules. We've got monoatomic, diatomic, triatomic. So you may see that term, okay, which means 1, 2, and 3 atoms. They connect at which makes that molecule. So if you want to explain in terms of electrostatic force of attraction, remember the definition. Electrostatic force of attraction means something positive and negative. So remember, no matter you are presenting covalent bond and ionic bond, you need to show something positive and somewhat negative. Somewhat positive and somewhat negative, okay? Or positively charged ions, which means positive and negative, right? To tell it is a type of bonding. And for 1C, with the aid of the electron diagram, describe how fluorine atoms makes a molecule. They share 1 electron to form such. So you are asked to draw the electron diagram. This one is the full, showing the full electron shell. So step back to the questions. If the question is just ask for outermost shells only, you may just hide some others. Can you get the point? Now it's your turn. It's your turn. Take a look on. Shall I speed up? For 8.3 is easy, right? 8.3, it is the hydrogen chloride, tetrachloromethane, etc. All those, they are just another example. Simply example, which tells you the other example, which shows you the different combination. It's not just element form. We can also have the covalent bond in compound. Hydrogen chloride is just one of the case. So hydrogen duplet. But for chlorine, we look for octet. So 1 single bond should be shared. Okay, you see such? Now, tetrachloromethane. Why is it tetra? Tetra means what? 4. Chloro means chlorine. Methane is something like this one is methane, right? But we cannot put the chlorine and H together because chlorine, because for carbon, we just have 4 outermost shell electrons. So what does it mean by tetrachloromethane? Those hydrogen will be replaced. to tell you it is a type of compound, CCl4. CCl4. So can we have trichloromethane? I give you one case, trichloromethane. What does it mean by trichloromethane? What is the formula? Anyone who can guess?
CCl3.
CHCl3. Okay,
Sorry.
CHCl3. Now, so why is it say CHCl3? Indeed, it's just a replacement of hydrogen atom, one from another, and while keeping each carbon connected to how many atoms? Just count 1, 2, 3, 4. Okay, 4 atoms. Can you see that? Each carbon, they connect to 4 atoms. Okay, you get my point. How about chloromethane? If I say it only as chloromethane, what does it mean by that? How many chlorine? As said before, one carbon, we have got 4 bonds. Okay, what does it mean by chloromethane? How many? How many chlorine? Just 1. So how about the remaining atoms? What is that? It is hydrogen. So the chemical formula is CH3Cl. Can you get the point? Of course, you may think of what does it mean by dichloromethane. Right? Dichloromethane means CH2Cl2. Is that clear? Now, how about ammonia? Ammonia, so you just spell like urine. So ammonia, we call it NH3. So strange. Very often H is usually put it on the left hand side, but this time you have to be aware of it. Okay, H is on the right hand side. Ammonia, NH3. So that sequencing, there is a reason behind. Okay, I don't want to explain that here, but for the others, if you want to know it, please check the concept of electronegativity. Okay, you will know it in the near the summer of Form 4 electronegativity. So you get to know that concept. Oh, sorry. I just put the word into only private message to one of you. Electronegativity. Now for those others, you may check this term, electronegativity. So again, hydrogen duplet, nitrogen octet. Water, hydrogen duplet, oxygen octet. Carbon dioxide, double bond. Okay, all 3 atoms are attaining octet. Okay, so simply speaking, maybe think of it is much related to the groups they are having. Okay, when you consider those how many electrons should be shared. Now, for example, if you are having the atoms which is in group 4, you just have 4 atomic shares. You look for 4 more covalent bonds, such as to make it octet. For group 5, we look for 3 single bond. We have group 6, 2 single bond, and 7 we look for 1 bond. Okay, is that clear? What is the final outcome? We look for what? Octet. Okay, but of course for hydrogen, no. Except hydrogen. Hydrogen we look for duplet. We look for duplet 2. Now it's your turn. Tell me, question 1. Wang Senghian, are you here? Could you please finish the electron diagram using the concept of dot and cross? Dot and cross. Do you have a pen? Now, anyone who have got a pen, now could you please finish this one? 8.2. No. Tell me what is the bond, the nature of bond, first of all. Nature of bond. Is it single bond, double bond, or triple bond? 羅康力
Hi.
F and O. What should be the connectivity of F and O?
Single bond.
Single bond for F and O. So for F, for F, which group does it belong to? It is group 7. So we have got 1, 2, 3, 4, 5, and 6 electrons and 7. Altogether, there should be 7 electrons. So what do they know is to share that is to ask for oxygen to give him 1 electrons. Okay, indeed, it's just a sharing of 1 electrons to make fluorine octet. To do the same, fluorine on the left-hand side and right-hand side, they have the same phase, okay? So the one O to share 1 electrons. So altogether 1 electrons. How about oxygen itself? Originally, how many electrons are there? How many electrons are there? Oxygen.
6.
Group 6. So we have got 2 electrons in outermost shells to involve in bonding. How about the remaining 4? They put it as a what pair? We call it lone pair. Okay? We call it lone pair electrons. Okay? Can you get my point? How about bond pair? Where's bond pair? Bond pair is here. Okay? Bond pair electrons. So each electrons comes the electrons that mix in the bond. How about this? Let's check. How about this? How about this? Is it bond pair or lone pair?
Lone pair.
Yes, lone pair, because it doesn't involve in the bonding. Okay, it doesn't involve in the bonding. So we call that lone pair. Can you get a point? Yeah. Okay. So Wang Senghin, you are here, right? Wang Senghin. Now
Yes,
take a look on question 2. Can you tell me the how to draw the electron diagram? If you don't know what is that, you may answer the molecular formula. You may answer either A or B. Wang Senghin. Yep.
Actually, do we need to use another color?
Hmm?
Do we need to
Yeah.
use another color to represent different element, the electron of different element? Do we need to use different color?
Different color is in the exam. In exam, you are sticking back to dot and cross instead. Now this time, why do I use different color is to let you know where the electrons they are from. Dot and cross is our common practice. So first of all, CS is the molecule we are looking for. Is it CS? Now you take a look on carbon. Carbon is got 6, atomic number being 6. Outermost shell electrons number is 4, right? Because it's group 4 element. It's group 4 element. So you have to stick back to this. How about 16 for sulfur? It's group 6. So hidden message is that whenever you have got 4, group 4, we would have carbon. They are connected to 4 single bond, right? Or what is that? It can be single bond, triple bond, or what? Carbon.
2 double bond.
Yep, 2 double bond. Okay, you get my point. So we have got that 3 combinations. How about this? Group 6 for sulfur. Sulfur, we have got group 6. In order to obtain octet, we need we need to share 2 electrons in order to obtain octet. So the combination is 2 single bond or 1 double bond. Okay, you get the point. So you are going to choose one combination which suits that carbon and hydrogen to make it octet. How? First of all, which one should be at the center? Is it sulfur or carbon?
Carbon.
Carbon, why?
Because carbon have four outermost shell electrons.
Okay, indeed, it needs more electrons to be shared in order to obtain octet.
Yeah.
Remember, okay, so the one which is not enough electrons, so you have to place it at the center. Remember center. So center, how about sulfur? They are at the terminal. So you write down sulfur is here. Okay, you got a point? Now what's next is to choose the combination. Which one is the best? This one, okay? Which one?
2 double bond.
Yes, double bond. Okay, you see that? Carbon with sulfur. So we've got sulfur. We have got 2 lone pair for each sulfur atom. As I mentioned before, it's group 6, right? Group 6. So you have got number 5, number 6, number 5, number 6. How about carbon? Carbon, it is indeed belongs to group 4. So we have got 4 electrons only. 1, 2, 3, and 4. Remember, those electrons involved in bonding should be put inside the overlapping circles in order to show the concept of sharing of electrons. So what is the final outcome? We would draw it like this in the electron diagram showing the outermost shells electrons. Or you use this to show the structural formula to show that it is the 2 double bonded molecule. We have got 2 double bonds. Can you get the point? Sang-Hin, do you understand now? So the molecular formula is CH2. CH2. C come first and then S next to it. But why not S2C? Why not? Is that the hidden rule? I said before, something about electronegativity. What is that actually? If you don't know what is the term, don't worry. Yeah?
As we should put the 即係細啲嘅嗰個 electronegative 擺喺前面啊。
Oh, the one which is less electronegative.
I just guess.
I put it in on the front, more electronegative at the end. Yeah, good guess. So what is mean by the highest electronegative element?
That mean the group more 即係右邊嗰啲咯。
yeah, you know a little bit. Yeah, indeed you know a little bit. Which element is the most electronegative? Do you know? Most.
It's chlorine.
Chlorine. It's fluorine, not chlorine. F.
Sorry.
It's fluorine. Okay, not it. Just get rid of noble gas. Take a look on the periodic table. Okay, take a look at the periodic table. And group 7, the topmost one, the fluorine, it is the most electronegative. What's mean by electronegativity? It is the tendency to attract the electrons in a bonding towards himself. So what is mean by that? We've got hydrogen fluoride as example. You may see there's a single bond here, right? So in which the fluorine, we have got a bonding like this. So we have got one electrons to be shared by hydrogen and fluorine each together. But that electron to form a bond, they will have a tendency, because they have got a stronger power, to pull the electrons towards the cell. What I mean is fluorine. So it seems that the sharing of electrons is not just the midpoint. It's not the midpoint of H and F atom. Is that it seems like pulling towards more to the fluorine. We would say that fluorine is more electronegative. So what is the results? The results is that this bond is said to be a little bit polar bond. So which means that the electrons, there will be an electron flow from positive to negative to form a slight charge. Okay, so we would say fluorine are more electronegative. So how about the other substance? They will stick back to the form, to the distance between fluorine. The one which is closer to fluorine, it is a higher tendency of pulling the electrons towards itself. So the form, is it like similar to our ionic compound, right? We write down NaF. Na is plus, fluorine is minus. It seems like a little bit slightly more negative. I put it at the back. Can you follow the logic? Very similar. Now, how about this? Now it's your turn. Can you stick back to this and try to come up with the chemical formula? Okay, who I just check. Who haven't said anything? Wang Junhei. Give the chemical formula of a covalent compound formed by when each pair of the elements combined. How many atoms that makes the molecule? Now go back to hydrogen. Hydrogen. How many electrons does it need to form to become stable?
One.
Just one. That means one single bond.
Yeah.
How about bromine? Group 7. Okay. So how many electrons does it need to share until it becomes stable? Just one.
Also one. Yeah.
Also one. So what is the combination?
HBr.
Yes, HBr. So the formula, we call it HBr with the single bond H and Br. Because bromine is more electronegative, so I put it at the back. How will you tell this? What is the name? Now, this is the chemical formula, right? Chemical formula is HBr. What is the name? Do you know how to call this name? Easy to guess, right? Just yell. According to what you understand about molecule, we call that
hydrogen bromide.
Good. Hydrogen bromide. Remember, a slightly positive come first, okay? No need to change the name, but slightly negative, I force it, I change the name to IDE. Is it similar to ionic compound naming system? Very similar, right? Very similar. So 李佩恒, take a look on B. Nitrogen and chlorine.李佩恒, are you here?
Yes.
Yep, let's try. Nitrogen, what is that group? Group 5, right? How many electrons does it need to have to share until it is octet?
3.
3. So it can be 3 single bond or 1 single bond, 1 double bond. How about chlorine? It should form a single, 1 single bond only. Can you get the point? So what is the combination? Remember the number as well.
NCl3.
Good. NCl3. Why is it NCl3? Because for nitrogen, I need 3 single bond. And chlorine, I need 1 single bond only. So I need to find 3 chlorine atoms for help. So how you call this?
Nitrogen chloride.
Nitrogen chloride. So now it is a little bit different system from ionic compound. We need to mention the number as well. So this time we call that nitrogen trichloride. So it is a little bit different. So this is the points of difference. Nitrogen trichloride. So similar case, you have heard it before. How about CO2? We call that carbon dioxide. Okay. How about H2S? Do we call it dihydrogen sulfide? No. Instead, we call that hydrogen sulfide. Oh, why is it so strange? Remember, the one I put it, I would mention the number at the right-hand side. So you may see that this is monosulfide. Okay. So no need to put it as this. And di, you put it here. But of course, why can't we use monohydride? Why didn't we use it? Because there are no other combination of hydrogen sulfide. Now, but for a carbon monoxide compound, we have got two. We have got carbon dioxide and carbon monoxide. It is for it is to clear your confusion, right? I don't want to make something ambiguous, so we would like to mention it as monoxide. Is that clear? So how about the last one? How about the last one?
SiS2.
SiS2. Yeah, that's right. SiS2. So using the similar concept, so silicon, it is Si. We have got 4 single bond. How about silicon having double bond? The answer is no. Now remember, for a single bond, double bond, or triple bond, for double bond and triple bond, they will only occur as small atom. Remember, okay? All of you, please mark it down. For double bond and triple bond, only happen when you are having small atoms, like what? Carbon, nitrogen, oxygen. Okay, just that 3. For the other combination, sorry, no. Silicon, we cannot have 2 double bond. Theoretically, mathematically, it's possible, but practically, it's not possible because silicon atom is too large. Okay, it's too large to have such. And sulfur, it is sulfur. It is what? Sulfur. It is double bond only. Okay, we've got double bond. So what we will get? SiCS2. But this part, it is rather not so stable. As said before, sulfur is a rather large atom. Okay, it's rather large atom. So this one is not so stable, I must tell. So the answer, what we call it, is silicon disulfide. Disulfide. Can you get a point? Can you get a point? Now you take a look on the last one. It is on this. Can you name this? I said before. Very strange example, right? This time it is nitrogen trifluoride. How about this? Now this one is really very tricky. According to the electronegativity, chlorine and oxygen, they are similar. They are similar. The chlorine next to it is fluorine on topmost. Oxygen next to it on the left-hand on the right-hand side, it is fluorine. So these two, they are very similar. So the naming is rather strange this time. We call that dichlorine monoxide. Dichlorine monoxide. Sometimes we need to show the substance, sometimes we need not. How about this? Number 2. Write the chemical formula of the following covalent compound. Dinitrogen trioxide. This N2O3 is rather unstable. How about this? Sulfur hexafluoride. SF6. But wait a minute, you take a look at F66, sulfur here, it is not octet. Do you realize? It's no longer octet. Can you find the case? We have got this substance, but this is not, but the sulfur here is not octet. Why would have some substances not obeying octet rule? You will know it in Form 4 summer. I will explain that to you later. Okay. Now, strange still. Now that molecular model, I'm sure you can read it by yourself. And this part, please finish it by yourself. The practice 8.5. It is your homework. Trying to do it by yourself. And we would have the drawing of those to get to know. And finally, and please read the dative covalent bond as a final example, a very strange example, and in which it is a type of sharing of electrons, but the sharing electrons, it comes from the same atom. So that's why we call it 叫做配位共介鍵, a dative covalent bond. It's a type of bonding in which both electrons come from the same atom. So take a look on the conditions of formation of that dative covalent bond. Okay, an example. I need the example as well of dative covalent bond. Okay, so for 8.9, we will skip that. Okay, we will skip that for the time being until we come up to the calculations part. You understand? And try it out. Class practice 8.6. Okay, this one is also homework. So we come to a brief summary of what is heard today. We come up with covalent bond. Covalent bond is what? It is an electrostatic attraction between the positively charged nuclei of the two bonded atoms. And what is negative? It is a sharing of electrons, right? But the bonding pair. So this is the definition. I would like to address your attention, first of all. The definition of covalent bond. Positively charged nuclei of the bonded atoms and negatively charged shared electrons. It is negative. We have got bond pair, lone pair. Involved in the bonding, we call it bond pair. Not involved in the bonding, we call it lone pair. And very often, what we will find it is covalent bond. It is not only found in element, but also in compound. Okay, and very often, you may find such in semi-metal and non-metal. So you may have such. Okay, so this is what I would like to share with you. And for the bonding, a covalent bond, we have got 3 types: single bond, for example, double bond, triple bond. Okay, and carbon, it is a very special example showing single bond, double bond, triple bond all together. Very strange. Okay, but not for many other non-metal atoms. Carbon is very, very special example. We have got single, double, and triple bond in their combination of atoms. It's now Thursday, right? You will have a face-to-face lesson on where? In Thursday, is it? Thursday. So which room are we having in the lesson? It's in Form 4 classroom, right? So we have you should have a punctual start, because we just have 30 minutes. We just have 30 minutes only. And how about the quiz? Do you still remember the quiz? The date of the quiz? When? Anyone who can tell the date of the quiz? Forgotten. I have mentioned in the Google Classroom. Tell me when.
Tomorrow.
On what topic?
Ionic Bond.
Yeah, Ionic Bond. Okay. So go home and please. Who said it's 29th of September? Maybe next week we'll have got another quiz. All right. So remember Ionic compound quiz. It is this time it's written, but not the formula.
先生
Yes.
我想問咧，啱啱咧提到關於嗰個 SF6 嗰嚿嘢噶嘛，咁我想問佢係咪都係穩定嘅？定係佢因為無啦啦成個佢唔 stable？ 哦，佢 stable。
It's stable. It's stable. It's stable. It is it's commonly used as you may find it into the real life. Okay, SF6. You just type it on the web, and this is a rather stable substances.
係因為有嗰啲 flora 喺出邊保護住佢定係點？所以佢 stable。
Now, for example, it is not necessary to be octet in order to set it stable. Now, some substances this is said to be already stable, but it's not octet. For example, sulfate. Sulfate. Why is it not octet? Sulfate. We have got 1, 2, 3, 4. So we have got 2 with a negative charge of oxygen. We have got single bond, single bond. So for sulfur, chlorine, and phosphorus, we have got the atom already in the third shell, right? We have got the electronic arrangement is 2x6, right? We've got third shell. Just remember the third shell, we would have this number. The first shell, they can accommodate at maximum 18 electrons, right? So they would try to make use of those electrons in the first shell to make such a bond. So whenever we have such combination, which means that the octet rule doesn't hold. We have got the expansion of octet. Okay, whenever the first shell have enough space for the incoming of the electrons, we have got quite a number of different combinations, having more than 8, but at the same time we call it stable. Okay, so you may find it a little bit complicated to comprehend, but that is the commonly seen examples in the world. Okay, it's not just always octet rule that holds all molecules or all substances to be stable. We have got such different combinations. SF6 is a colorless, no smell, not flammable, not toxic substances, but it is a said to be a potential greenhouse gas. Electrical insulator, okay, is a non-polar gas. Somebody will say that fluorine is electronegative, but altogether the whole shape is said to be non-polar. It's non-polar,非極性, no charge. Okay, so the application is a medium for doing some electrical industry experiment because it's so stable. Okay. Any more questions? Now we just stop here, and we'll see you guys this Thursday face to face. Okay, at school. Bye bye.